Right, the question is to find the highest lower bound and the lowest upper bound that are integers for this polynomial, for the zeros of this polynomial. Now I'm going to check Descartes' rule of signs first to see if it's even worthwhile to do this. So I'm going to check f of x and see how many sign changes there are. So it goes negative to plus, that's 1, plus to minus, that's 2, minus, 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 plus 3. So there's either going to be 3, 2, not 3, 2, 3 or 1. It always goes down by even number. 3 or 1 positive real roots. And then f of negative x, in other words, I'm going to change the sign of anything that has, any x that has an odd power. So this one is still negative, this is negative, this is negative, this is positive, this is positive. And how many sign changes are there? Just 1. So this has 1 negative real root. So it is going to be worthwhile to find upper and lower bounds. Now, you don't always have to find maximum lower and minimum upper. If you're trying to find upper and lower bounds, generally check what are the potential rational roots. In other words, I take the final number, 25, plus or minus, and all the factors of it, and divide it by plus or minus the leading coefficient, all the factors of it. So this would be plus or minus 25, 5, and 1, divided by plus or minus 1. Those are all the integers. So that would give me starting points to find upper and lower bounds, but if I have to find the maximum lower and minimum upper, I might have to use other integers, because let's say 5 is an upper bound. Well, it might not be the lowest upper bound, but this gives me a good starting point. Now, normally with the upper and lower bounds test, the leading coefficient should be positive, because for the upper bounds test, when I do synthetic division, the result, all the numbers in the bottom row, have to be positive, but that's impossible because the first number here is negative. So instead of looking for all positives, since it starts with a negative, I just look for all negatives. You could also just multiply by -1 the whole polynomial and then look for all positives. Recognize that if a polynomial looks like this, say x squared, and I make it negative x squared, it's all of a sudden going to go the opposite way. But the roots are still going to be the same, so it's valid to do that. So I'm just going to use the coefficients of this, -1, 5, -4, -9, and 25. And I'm looking for the least upper bound, so I want a positive number, and I'm going to look for all negatives. All of these last row must be negative if this is an upper bound. And I'll try, I'm just going to use the possible rational roots. I'll try +5, see what happens. So this is -1. 5 times -1 is -5. 5 minus 5 is 0. 5 times 0 is 0. -4 plus 0 is -4. 5 times -4 is -20. -20 plus -9 is -29. 5 times -29 is -100 minus. -100 plus 25 is a negative. So this is negative. This is 0, which is neither positive or negative. So it can count as either one. So I'm counting it as negative here. Negative, negative, negative. So they're all negative. 5 is an upper bound. So I'm going to put this upper. I'll just put a U. So wait a minute. I want to delete all this because I want to try different numbers, and then I'll rewrite my 5 as an upper bound. Okay, so 5 is an upper bound. All right, but could there be a smaller integer? I've got 1, 2, 3, 4 that are positive and smaller than 5 that could be upper bounds, and I have to check them since I'm looking for the least upper bound. However, notice this first number is always going to be -1, and I want this whole bottom row to be negatives here. So if I do 4 or 3 or 2 or 1, 4 times -1 is -4, 5 plus -4 is +1. And I don't have all negatives. So 4, 3, 2, or 1 aren't going to work. And so I can see that my lowest upper bound, that's an integer, is 5. Now I want my largest lower bound, and that's going to be, I can just leave it these negatives, and I want sign changes. I want negative, positive, negative, positive, negative. And if that's the case, then it's the lower bound. Since it's asking, and again, I could try the possible roots, like I could try 5, you know, the middle one, and see if that works. But since it's asking for the highest lower bound, I'm just going to start, 5 isn't that far to go, or -5, so I'm going to try -1 first and see if that one works. So here's -1. If I get any time where there's two same sign in the row, it's done. -1 times -1 is 1. 5 plus 1 is 6. -1 times 6 is -6. That's -10. -1 times -10 is 10. That's +1. -1 times 1 is -1. 25 minus 1 is 24. Whoops. 2 positives in a row. So -1 ain't it. So now I'll go to -2. And I'm just starting at -1 because it wants the highest lower bound and it's an integer. And I know I could try ±1, ±5, ±25. Those are the possible rational roots, but it could be other integers in there that are the bound. So I'm just going to go from -1 up, -1 down, and see if one of them works. -1 is out, so if -2 works, it's the highest lower bound. So this is -1. -2 times -1 is 2. 5 plus 2 is 7. -2 times 7 is -14. Minus 4 is -18. -2 times -18 is +36. Minus 9 is +25. -2 times 25 is -50. Plus 25 is -25. And I've got negative, positive, negative, positive, negative. They alternate each time. Therefore, the lower bound is -2. So 5 is the lowest integer upper bound, and -2 is the highest integer lower bound. And I use that by doing the upper lower bound tests. And I did the Descartes' rule of sign just to see if it was useful. Like if I had found that there were no possible negative real roots, I wouldn't even bother doing this test. But there's the answer.